If you open an Epson inkjet cartridge, you'll find a complex series of chambers, channels, walls, and holes. But what's the purpose of this mess? Why are Epson inkjet cartridges so complicated? To understand the technology behind Epson ink cartridges, I read the Epson patent. It's a 17-page document, but the most difficult part is that it was originally written by the Japanese inventors in Japanese and poorly translated into English. Nevertheless, here's what the Epson patent reveals. To begin, the patent describes the cartridge as a detachable container that supplies ink to the printhead. Epson chose not to use sponges inside its ink cartridges, unlike HP, for example, because this design allows all the ink in the cartridge to be used, whereas with a sponge, some ink remains trapped and cannot be utilized. But without a sponge, the ink inside the cartridge is free to move. Epson observed that during printing operations, the carriage holding the ink cartridges moves at high speed, causing pressure fluctuations in the ink due to acceleration and deceleration. This led to unstable ejection of ink droplets from the printhead and the formation of bubbles in the ink, which could clog the printhead nozzles. To address this, Epson designed a cartridge in which the ink is contained within smaller chambers, limiting the movement of the liquid. The components of the cartridge are lower ink storage chamber, upper ink storage chamber, secondary ink chamber, another chamber containing a membrane valve that regulates the flow of ink, a channel connecting the valve to the ink supply port that provides ink to the printhead. How does this system work? A negative pressure in the ink is generated at the printhead. This pressure opens the valve. As ink consumption at the printhead continues, the ink in the first storage chamber flows into the second storage chamber through this channel. The ink continues the path, driven by negative pressure. It reaches the second chamber, then moves upward through communication passage, and finally arrives in this area. It passes through the filter and enters the storage chamber of the differential pressure regulating valve. Then, the ink follows the channel that leads to the printhead. How does the valve work? This is the valve. The valve is an elastically deformable film that, when the printhead does not require ink, is closed by a helical compression spring. This one. This is the valve seen from above. When the printhead calls for ink, the pressure in the printhead decreases, allowing the membrane valve to overcome the force of the compression spring, opening the hole of the valve. This is the hole where the ink passes through. Then the ink passes through the valve hole and flows into the ink supply port. When the printhead is in standby mode and does not need ink, the ink pressure in the printhead increases. The membrane of the valve is pushed by the pushing force of the helical compression spring, closing the hole and stopping the ink flow. This is why it's not possible to refill the cartridge through the ink port, because when the cartridge is not inserted into the printer, the valve membrane is closed and the ink cannot reach the ink chambers. The cartridge is open to the atmosphere through this maze of grooves on the back of the cartridge. These are ventilation channels connected to the cartridge's ink storage chambers. As the ink is consumed, air flows into the cartridge through these holes. Since the air bubbles in the ink are moved up by a buoyant force that makes them float, and since the holes connecting the ink chambers are located at the bottom of the chambers, the air does not reach the printhead. These ventilation holes are closed when the ink cartridge is not inserted in the cartridge holder of the printer. Inserting the cartridge opens it to the atmosphere, allowing the ink to flow. Therefore, correct insertion of the cartridge is essential. A non-functioning cartridge may be due to deformation or breaking of the cartridge or of the cartridge holder. Why don't the cartridges leak ink? Before installation, there's a seal glued to the ink port. The tip of the printhead pierces this seal. Then, there's a spring-loaded cap that closes the hole. This is the cap. I removed it from an Epson cartridge. When you insert the cartridge into the printer, the tip of the printhead pushes up the cap and opens the ink port. The patent describes the circuit board, the chip, as a storage device retaining information data concerning ink, color, pigment or dye-based ink type, ink remaining amount, serial number, expiration date, model of the printer. There are identifying parts on the back of the cartridge that prevent a cartridge from being inserted into a slot of a different color than the cartridge itself. This prevents the wrong color of ink from contaminating the printhead. Compatible cartridges often do not have this part. Half of the patent concerns the method of injecting ink into the cartridge. In simple terms, the cartridge is placed upside down, and the tips of two ink injectors are inserted into two openings of the ink cartridge. One of the tips injects ink into the first ink chamber through the opening 86B. This one. Another tip injects ink into the second ink storage chamber, the third ink storage chamber, up to the ink supply port through the opening 85. This one. At the same time as the cartridge is being filled, the air inside the cartridge is sucked from the ink supply port, so there is no air inside the cartridge. Excessively injected ink may also be discharged through this nozzle. After filling the cartridge, all the three openings are hermetically sealed. One of the filling holes becomes the glass window of the ink sensor. We can conclude that such a complex ink cartridge design serves two purposes: to prevent the formation of air bubbles inside the cartridge, and to make it easier for Epson to sue anyone producing compatible cartridges for copyright infringement.